This PowerPoint is over a design process. I'm going to go over in this PowerPoint what is design, what is a design process examples, design process used in IED, which is Intro to Engineering Design. So what is design? The word design is often used as a generic term that refers to anything that was made by a conscious human effort. Design is also a process that is used to systematically solve problems. You use design in your everyday life all the time. As simple as just getting ready for school every day can be considered a design process. So a design process is a systematic problem-solving strategy with criteria and constraints used to develop many possible solutions to solve or satisfy human needs or wants and to narrow down the possible solutions to one final choice. So this picture on the left is a picture of von Braun from 1964 using the design process. Right? And the second picture is a picture of a NASA engineer in 1971 working with the Saturn V model. All right, so the design process, there's various design processes are used across different technical fields. The following are examples. As I go through these examples, you'll notice that there's kind of an overall theme to it. Maybe the words have changed, the numbers have changed, but it's really kind of the same thing. Also, several design processes are used successfully in both industry and education. And this is the design process you'll be using this year in Introduction to Engineering Design, as well as your other Project Lead the Way courses you'll be taking in following years. Right, so design process used in Intro to Engineering Design is an example of one design process. Many design processes exist and are effective. Consistently applying a single, clearly defined design process provides a basis for understanding. All right, so we'll break apart each part of our design process you'll be using this year. The first one is define the problem. Now you're going to identify a problem. You're going to validate the problem. Who says it is a problem? What is its needs and wants? The prior solutions that have already been thought of? Justify the problem. Is the problem worth solving? You're going to create design requirements, specifications, like the criteria and constraints that will need to be used. All right, and then you're going to put that all together in a design brief. All right, so a design brief is a written plan that identifies a problem to be solved, its criteria and its constraints. And I'll show you later how to do that in a different PowerPoint. All right, it's used to encourage thinking of all aspects of a problem before attempting a solution. All right, so in some cases, if the problem is not valid or justifiable, the designer must define a new problem. Right? If it is justified or valid, you're going to move on to the second step, which is generate concepts. In this, you'll do research, you'll brainstorm possible solutions, you're going to consider additional design goals. You're going to apply STEM principles. STEM is science, technology, engineering, and mathematics. You're going to select an approach. And then you're going to also select that approach using what's called a decision matrix. So decision matrix is a tool used to compare design solutions against one another using specific criteria. This is an example of a decision matrix, and later in another PowerPoint we'll also be going over how to actually make one of these decision matrix. Whenever you finish, you'll notice on the right where it says total, one has 11, the rest have less than 11. So idea 6 is the one that would be used. Right? So then you need to figure, do you need more technology for this solution? If the technology necessary to develop the solution does not exist, scientific research may be necessary to pursue a solution. If you do have the research is needed, solution is valid, you're going to move on to develop a solution. Right, create detailed design solution. You're going to justify the solution path. You're going to do technical drawings. In this particular course, we're going to make those either by hand sketches or by using Autodesk Inventor. Right, so technical drawings are drawings that provide technical information necessary to produce a product. The material, the size, the shape, assembly if necessary. So now, is the solution valid? Yes or no? If the solution is found to be invalid or cannot be justified, the designer must return to a previous step in the design process. Okay. If it is valid, you'll move on to the next step, construct and test a prototype. Construct a testable prototype. You're going to plan the prototype testing, its performance, its usability, its durability. After you've planned how you're going to test it, then you'll actually test the prototype. And then you're going to collect test data at that time. Analyze the test data, and you're going to put it into a test report. All right, so at this point you need to decide, is the prototype valid? If a testable prototype cannot be built or test data analysis indicates a flawed design, the designer must return to a previous step of the design process. Right? If it is valid, you'll move on to evaluate your solution. Okay, so you evaluate the solution's effectiveness. You'll reflect on the design, recommend improvements. You're going to optimize redesign of the solution. Right, so sometimes you'll need to return to prior design process steps if necessary. And you're going to revise design documents if you have redesigned or optimized your solution. Okay, and then you're going to give product recommendations at this time. Okay, so if the solution solves the problem, then you would move on. If it does not solve the problem, the designer must return to a previous step of the design process. Right, so if it did solve the problem, now you're ready to present your solution. All right, you're going to document the project in a project portfolio. You're going to communicate the project, usually in a formal presentation. All right, so iterative is a process that repeats a series of steps over and over until the desired outcome is obtained. So when you're doing this step in your engineering notebook, if you have to go back up and redesign or redo one of the steps, you will continue on in the engineering notebook, just going back and forth along the steps, as long as you're using the overall design process overall. All right, so although we have presented a design process in somewhat linear fashion, the path from identifying a problem to presenting a solution is rarely straightforward. Designers must evaluate, reflect, redesign, and refine throughout the process. It is common to repeat steps of the design process several times before an optimal solution is found. Right, so product improvement or redesign will require the designer to repeat the design process then.